Hello, Stuart Sumner here, interactive presentation number 7. Today we're talking about electron domain and molecular geometries of molecules with lone pairs, without lone pairs on a central atom, and we're going to be using balloons. Got a bunch of balloons here to show their configuration. Now, I already blew up the balloons to save time, so I'm going to run through the 5 electric domain geometries. First, we have linear, okay, straight line. Then we have a trigonal planar. So there's 3 electron geometries, but they're all on the same plane. We have a tetrahedral. Here. And then we have a trigonal bipyramidal. Kind of like this, where you got 3 and then 2 bisecting it. And then we have the octahedral. I'm sorry, these balloons aren't all the same size. This one might be losing air. But you have four on plane and then 2 bisecting it. Okay, so what we can do with these molecules, starting with the trigonal planar, is there's 3 electron domains here. Okay, and the geometry is called trigonal planar. If there's one lone pair on the atom, it would be up here on the central atom, and that would cause like a bent formation. So like an example of that would be SO2. And then with our tetrahedral, the type of molecule that is a tetrahedral is an AB3 molecule. Alright, so with one lone pair, it'd be trigonal pyramidal, and an example is NH3. With 2 lone pairs, the molecule would look bent, and H2O is a good example of that. So our trigonal bipyramidal, which has 5 electric domains, if it had a lone pair, 1, it could be seesaw shaped. An example would be SF4, where you'd have like 4 molecules all on the line. Oop, I lost one there. And then if you had 2 lone pairs, it could be T-shaped. So it looked like that, like a T. Also, you could have a linear shape if you had 3 lone pairs, where the the lone pairs would be here, here, and here on the central atom, and the molecule would just look linear. For octahedral, it's an AB5 molecule with one lone pair. It looks square pyramidal. Trying to show that. And if it had two lone pairs on the central atom, we could actually make it square planar, where the central atom, the 4 electron domains would be plane, would be on the same plane to that central atom. So it's cool to use the balloons as a helping tool to kind of see how the electron domains work. It can be a pain tying the balloons up. I feel like a circus clown, but it's a very good visual aid to help explain how the electron domains work, and it's pretty cool, especially if you need help like studying how it works and just seeing it visually in your head. So thank you. We'll see you next week for week 8.